Next, introduce you a binomial experiment. A binomial experiment consists of n independent and identical Bernoulli trials. Okay, for example, random experiment 1. Flip a bias coin 3 times. It's a binomial experiment. Okay? Now, when we say bias, what does that mean? Well, we say probability of getting heads is 1/3. Is this one. Is the chance of this bias coins to get a head. When I say probability of getting heads 1/3, what does that mean? That means when you flip the coin 300 times, you expect to see 100 heads. This is a binomial experiment. Okay? This is a binomial experiment. Now, why this is a binomial experiment? Let's check those conditions one by one. First one, n is a predetermined number. Okay, n is a predetermined number. In our example, this predetermined number is 3. N equal to 3 in our example. And you know n equal to 3 before you do the experiment. People may ask, what kind of situation n is not predetermined? For example, I keep flipping a coin and I'm not going to stop until I see a head. If this is a random experiment, then you have no idea how many times you need to flip the coin to get the first head. Okay? In that case, n is not predetermined. But in our case, no matter what you get, you only make 3 flip and then you stop. So n is a predetermined number. Second one, it's a Bernoulli trial. Because in this experiment, each flip, either you see head or you see what? A tail. You have only what? 2 possible outcomes. You can only see 2 possible outcomes. And 3, identical trial. When we say identical trial, what does that mean? That means probability that first flip, we see a head, equal to the probability that second flip, we see a head, equal to probability that the third flip, we see a head. And those probabilities are all equal to what? 1/3. Why is that? Because we are flipping what? The same coin. So each flip to get a head, the chance is exactly the same. They all equal to 1/3. And the last one, check independent. Okay? Because we make the flip what? Independently. So we do have independent flips. After we check these 4 conditions, we find they all satisfy what? The definition of a binomial experiment. That is, a binomial experiment consists of n independent and identical Bernoulli trial. Okay? Now, let's next talk about a binomial experiment. A binomial random variable. A binomial random variable, x. What is x? Okay? Well, X is defined to be the number of successes in a binomial experiment. We define X as the number of successes in a binomial experiment. So if this is our definition, then X will follow. Okay, this notation we read as follows. X follow a binomial distribution. A binomial distribution consists of two parameters. First one, n. Second one, pi. So when I say a binomial random variable, when I say X follow a binomial distribution, there are two population parameters. N is a number of, this is a number of, the number of Bernoulli trials. And pi is a probability of getting what? Success. Okay? So this is how we define a binomial random variable. Now, claim. Claim 1. A binomial random variable is a summation, the sum of n independent and identically distributed Bernoulli random variables. Okay? A binomial random variable is a summation of n independent and identically distributed Bernoulli random variables. That is to say, in our example, okay, let X be what? Let X be the number of heads resulting. Okay? So, I can rewrite X as x1 plus x2 plus x3. And here, xk is 1 or 0. It's 1 if the case free. If the case free is a head. If it is 0, if the case free is a tail. So when I flip the coin 3 times, if I see head, tail, tail, then x1, x2, x3. x1 is 1, x2 is 0, x3 is 0. So what is x? X is x1 plus x2 plus x3. So that is 1 plus 0 plus 0. You flip the coin 3 times, you find only what? Only one head. Okay? So a binomial random variable is a sum of n independent and identical what? Bernoulli random variables. Okay? Now, next one, let's talk about the expected value and the summation. The expected value and the variance of a Bernoulli random variable. Okay? if x follow binomial with parameter n and pi, then x is equal to x1 plus x2 plus all the way up to xn, where x1 up to what? xn is a sequence where x1 up to xn is a sequence of independent and identically distributed. Bernoulli random variables. Okay? Now, that is to say xk follow what? Bernoulli with parameter pi. Okay? Now, second one. The mean of a binomial random variable. Because we know x is equal to what? x1 plus x2 plus all the way up to xn. By applying the property of expected value, we can rewrite this one as x1 plus ex2 plus all the way up to exn. But what is ex, as I mentioned before? Recall, expected value of a Bernoulli random variable is a probability of getting success. So this is pi. This one is still pi. And they are all equal to pi. Okay? exk is pi. Okay? And why they all equal to pi? Because this is identical. So far so good? They are identical. So how many of them? N of them. So it's n pi. So mean of what? A binomial random variable is n times pi. N is the number of Bernoulli trial. Pi is the chance of getting success. For example, if I give you a fail coin what? Flip. Example. If we flip a fail coin 100 times, then how many heads? Let x be what? Number of heads resulting. If I give you a fail coin and ask you to flip the fail coin 100 times, how many heads do you expect to see? Applying this formula, flip a fail coin 100 times is a binomial experiment. Expected value of x is what? N times pi. Okay? N here is 100. You flip the coin 100 times. And since this is a fail coin chance of getting heads is 50%. So 100 times 50%, give me what? Give me 50. Is that clear? So expected number of heads resulting will be what? Will be 50 heads. Okay? And that makes sense. Now next one, we talk about variance of x. Variance of a binomial random variable. Let's try again. It's the variance of what? x1 plus all the way up to xn. Okay? Now, next one we can apply what? The property of variance. That is variance x1 plus x2 plus all the way up to xn is variance x1 plus variance x2 plus all the way up to variance xn. However, there is a condition need to be satisfied, and that is independent. Okay? That is independent. But do we have independent assumption here? The answer is positive. Look at here. We say x1 up to xn is a sequence of independent and identically distributed Bernoulli random variable. So we do have independent here. So this operation is what? Legitimate. Now, let's recall. what is the variance of a Bernoulli random variable? Remember, it's the product of two probabilities. One for success, one for failure. And you have how many of them? You have n of them, okay? So in this case, variance of x is n times pi times 1 minus pi, okay?